Okay, so here we are, continuing this example. And here we are looking at the second page of the table of values for the cumulative standard normal distribution. That's what it says right there. Okay. All right. So these are the z values. And the way that we look up the left area is pretty simple. We are going to align the first two digits, so the ones and the tenths place of our number. Our z number is what? 1.73. So we're going to find 1.7, right? And then going across the columns here, we see 0.00, 0.01, 0.02, 0.03. So we're going to go to 0.03. We're going to align where, let me see, I can do this trickily here, where 1.7 and 0.03 meet up. And so we're going to go down this column here and over across this row to this value right here. We're going to read off what that says. What does that say? I lost the value. Can't read it very well. Okay, sorry, my old eyes here. Okay, and after going and fetching my reading glasses, I can now see that this value says 0.9582. So let me just jot that down. Right, so our probability or the area is equal to 0.95, oh, can't see that, 82. All right, just gonna recall that so we don't forget that. And going back to the problem that we were doing, that is our area underneath the normal curve. So let's point to it like this and put 0.9582. Okay. So just to add a little bit of clarity here, what this represents is if we were looking at the standard normal distribution, we would be seeing that the proportion of values that have a z-score lower than or equal to 1.73, that's exactly what? 95.82% of the values. So here we're basically looking at the relative position, the z-score, and determining where that data value or that data value that has that corresponding z-score would fall within the rest of the data set. So let's do one more example. I'm just going to make up another example of a left area. And let's find the left area for z equals negative 0.35. Okay, so how would we do that? All right, so we'll start out the same way, right? Just to kind of get into this as a habit. So we'll say, here's my distribution curve. All right, fine. It's not a great sketch, but we'll live with it. All right, so there's 0 in the middle. Okay, don't necessarily have to show anything for that. Where's negative 0.35? I have no idea. I forgot my measurement device, but I know it's to the left of 0, so I'll just write it there. Okay, and now I want a left area. If I had written this out in full English, I would have said, find the area underneath the standard normal distribution curve to the left of z equals negative 0.35. But I didn't have time to write all of that, so I didn't. But anyway, so we sketched the curve, we found our z value, and we shaded in the appropriate area. That basically just gives us a nice mental picture of what it is that we're going to be looking for. All right, so now go back to the normal table, cumulative normal distribution table. And now you'll notice that our z-score is a negative number. These are fine. Z-scores can be negative. That's legal. As long as your value is below whatever the mean is, then its z-score is going to be negative. But that just means I have to flip to the first page of our cumulative standard normal distribution. That would be 779 in the book. It would be A11. But on the little pullout, it's just, there it is. Okay. How do we look up this z value? What was the z value? The z-score was negative 0.3. So let's see. We're going to go to find negative 0.3. Okay. Go up a little bit. Let's pull up. Where's that? So there's negative 0.3. All right. And then that was not all of our z number. So basically, like, this is kind of like a stem and leaf plot, right? So our stem is going to be the ones and the tenths place, and then the leaf is going to be the hundredths place. So the stem will find this on the row, and then the leaf one, this one, will find this on the column. Okay. So it's kind of cut off. Let me see. We're going to go up to 0.05 and negative 0.3. Because putting those together, that gives us the z value of negative 0.35. And where do these intersect? We're going to line these up like so. So they intersect in the value 0.3632. And so that is the left area that we would have there, 0.3632. Okay, so we'll pause this video here and we'll move on to finding other types of area.